Good morning, friends. In the previous lecture, we were solving about the practice related to the topic, that was the polynomials, and in the previous lecture we discussed about the which of the following were the polynomials in one variable. Now the second question, today we are going to solve it about write down the coefficients of the term x square in each of the following. I'm going to write down some questions here and you need to mention down the coefficients of each of the following, coefficients of x square in each of the following. The first one is p of x is equals to 2 plus x square plus x. The second one is p of x is equals to 2 minus x square plus x cube. The third one is g of x is equals to pi by 2 x square plus x. The fourth one is p of x is equals to root 2 x square plus 1. So friends, right now we are having these four questions with us, and in each of these following questions the questions numbered from 1 to 4, you need to mention down the coefficients of x square in each of the following here, right? So first of all, let us start with the first question here. The coefficient of x square here in this question, in this example, is the number, the constant multiplied with the variable x square, or the constant associated with the number or the variable x square here is its coefficient. So if I look at this term x square here, there is no number which I can see there physically, but actually the number that is present over here is 1, and hence the coefficient of x square is equals to 1, right? So the coefficient of x square here is equals to 1. See friends, if you cannot see any number there physically with x square, if you see any term like only x square, then the number that is multiplied, the constant that is multiplied over there is 1, because 1 into x square is again x square. Similarly for the second one, if I say that if I want to find out the coefficient here, then the term x square has a minus sign over there, right? This term here has a minus sign over here. That means if I write minus x square, this simply means that minus 1 into x square. See, minus 1 into x square is again minus x square. So if I write down minus 1 into x square, that is minus x square, and hence the coefficient of x square, coefficient of x square is minus 1 here. Is it clear, friends? So if you have any variable multiplied by a negative constant, let me say for example x cube, but that is minus, then the coefficient of x cube is minus 1. If it is minus 3x, then the coefficient of x is minus 3. Is it clear? That minus is to be associated or is to be taken in consideration with the next term. If it is 2 minus x square, then it is not like 2 minus x square. That means all the three terms or all the three things are different. This minus is to be considered with the next term, that is 2 minus x square plus x cube. Is it clear, friends? So that minus is being carried over to the next term. Then we are having the third example, that is g of x equals to pi by 2 x square plus x. So the coefficient of x square here that is pi by 2, Why? Because this number, this constant pi by 2 is multiplied by the multiplied with the variable x square, and hence the coefficient of x square here is pi by 2. In the same way, for the fourth example, the coefficient will be of x square will be equals to root 2. Is it clear? So I want to let you know that all these examples are of different kinds. So if any one of these or if any one of these kind is asked, then you must know how to find out the coefficients of any of the term rather than finding out the coefficient of x square. If I say to find out the coefficient of x in each and every question, then the coefficient of x in the first term, in the first question is 1. Here there is no x, there is no term with variable x present, hence the coefficient of x is 0. If I say for the third one, then again the coefficient of x over here in the third question is 1, and for the last one again there is no term with the variable x present, so the coefficient of x is 0 again there in the fourth question. Is it clear, friends? Now I am having one more question that can be asked here in this examination or in the coming examinations, that is, write down the degree of each of the following. Right, we need to write down the degree of each of the following. Let me write down the questions here. The first one is p of x is equals to 5x cube plus 4x square plus root 7x. The second one is p of x is equals to 4 minus x square. The third one is g of t is equals to 5t minus root 7, and the fourth one is p of x is equals to 3. Right, so as we discussed in the degree means what is the definition of the degree of a polynomial? Degree of a polynomial simply means the highest power of the variable present in the polynomial is called the degree of that polynomial. The highest power, friends. So we are going to look for the highest power in each of the following examples that are given to us here. Okay, so the highest powers of each of the following examples are respectively as we look for the first one, the highest power in the first question here is 3, as we can see here. So the degree is 3 here, right? So the degree of the polynomial here is 3. Then for the second one, as we see, the second one is a polynomial p of x is equals to 4 minus x square. So as there are only 2 terms present, the degree of this polynomial here will be selected from these 2 terms only, either from the 4 and from the x square. So again here the degree is equals to 2, right? Because x square is present over there and the highest power taken to be in consideration is 2. So the degree here is 2. Similarly for the third one, g of t is equals to 5t minus root 7. Again here degree is 1, right? And for the last one, this is a question, or this is an example of a constant polynomial, and hence the degree of a constant polynomial is 0. Is it clear, friends? So we got the degrees. The first one has a degree 3, the second one has a degree 2, the third one has a degree 1, and the fourth one has degree 0. Let us quickly note that what are these polynomials classified as based on the degree. So if it is a polynomial of degree 3, then that is known as a cubic polynomial. Then second one is a quadratic polynomial. The third one is a linear polynomial, and the fourth one is a zero or a constant polynomial. Is it clear, friends? This might be clear to you because this is the thing that we have learned in the classification of the polynomials, that a polynomial of degree 3 is known as a cubic polynomial, a polynomial of degree 2 is known as a quadratic polynomial, a polynomial of degree 1 is known as a linear polynomial, and that for a 0 is known as a zero or a constant polynomial. Okay. Now, in the next thing, we are going to again classify the following questions. We are going to classify the questions. I am having some of the questions here with me, and we are going to classify them into the categories that we have based on the degree of the polynomial. So classify the following. Classify the following as linear, quadratic or cubic polynomial. Right? Okay. Let me write down the questions here. The first one I shall write down in the form of ABCD. The first one, P of x is equals to x square plus x. The second one, P of x is equals to x minus x cube. The third one, G of y is equals to y plus y square plus 4. The fourth one, it is 1 plus x. The fifth one, it is 3t. The sixth one, r of s is equals to s square. And the seventh one again, p of x is equals to 7x cube. Right, so I am having these 7 examples here with me right now, and we are going to classify them based on these 3 categories, that is whether they are linear, quadratic or cubic. So linear polynomial, if the degree is equals to 1, then that is known as a linear polynomial. If degree is equals to 2, that is known as a quadratic, and degree is equals to 3, then that is known as a cubic. Let us classify them. The first one is having a degree 2 because there are 2 terms present here, that is x square and x, and the highest power of these 2 terms present is 2. That means the degree of this polynomial here will be 2, and if it has a degree 2, then that is a quadratic polynomial. Yes or no? If it has a degree 2, then that is known as a quadratic polynomial. Then the second one. See friends, second one also contains 2 terms. One is x and another one is minus x cube. Right? But if you see here, their powers, the first term has a power 1 and the second term has a power 3. That means the highest power from the present variables or the present terms is 3, and hence this is known as a cubic polynomial. Right? It is known as a cubic polynomial. Then looking for the third one, the third question is g of y is equals to y plus y square plus 4. In this question we are having the highest power 2. That means it will be a quadratic polynomial. In the fourth question, There are again two terms, one is 1 and the another one is x. 1 is a constant term because it has none of the variables present, and the another one is x. So the highest power between these two is 1, and hence it is a linear polynomial, right? The fifth one, g of t is equals to 3t. Again there is only one term present, and which is again associated with the variable t having power 1. So again that is a linear polynomial, right? Fifth one, it is s square. R of s is equals to s square. S square, that means only one term with a power 2, that will become a quadratic polynomial. And lastly, the seventh one, again with a single term, 7x cube with power 3 for the variable x, so that is a cubic polynomial. Is it clear, friends? So the first one is quadratic, second one is cubic, third one is quadratic, fourth one is linear, fifth one is linear, sixth one is quadratic, and lastly we have a cubic polynomial, right? So that is about how the polynomials can be classified into these three categories, whether they are linear, quadratic or cubic polynomials. Is it clear with this, friends? Okay. Now we are going to move on to the next topic, and an important one, that is the zeros of a polynomial. Zeros of a polynomial. Zeros, what do you mean by zeros, or simply zero? When it comes to a zero, we come with a thing in mind that it will be round in shape, it has no value before a decimal point, and if it has every value after a decimal point, right? Now if I say that these zeros of a polynomial are basically the roots that we found out in the quadratic equation in the previous standard. Suppose if we found out the roots of a quadratic equation, I don't know whether you have studied or not, but we have already factorized the quadratic polynomial in the previous years, right? Now when those factors are equated to 0, at that time we get the values of the variable, which leads us to the roots. So these zeros are basically that value of the variable x at which the value of the whole polynomial becomes 0. Let me write down the definition, basic definition according to me. It is the value of the variable, it is the value of the variable present in the polynomial or present in the question, for which the value of whole polynomial becomes 0. It is the value of the variable present in the polynomial for which the value of whole polynomial becomes 0. That means we are finding out the value of the variable x. Zeros of a polynomial basically means the values of the variable for which the value of the whole polynomial becomes 0. value of the whole polynomial becomes 0. How? Let me take an example here. If I am having a polynomial p of x that is 4x plus 1, right? If I am having this example here, that is p of x is equals to 4x plus 1, for example, let me say, right? 4x plus 1, what kind of a polynomial is this? It is a linear polynomial, and it is again a binomial, because there are two terms, so that will be a binomial, and it has a degree 1, so that is a linear polynomial. Okay, if I want to find out the zeros of this polynomial, then let me say that in this p of x, let x equals to minus 1 by 4. If I assume that the value of x is minus 1 by 4, then what? If I replace this x equals to minus 1 by 4 in this question, therefore p of minus 1 by 4, that is 4 into minus 1 by 4 plus 1, this 4 and 4 is cancelled, and hence minus 1 plus 1 is 0. So we got the value of p of x as 0. Let me don't write down here as p of minus 1 by 4, because I think you might not understand like this. So p of x is equals to, what did I do? I put that value of x equals to minus 1 by 4 here. So that is minus 1 by 4 into 4. 4 and 4 cancelled. That is minus 1 plus 1 is 0. It simply means that the value of p of x right now is 0. Right? The value of p of x right now here with us is 0. So if it becomes 0 here, at what value did the value of p of x become 0? At x equals to minus 1 by 4. That means this x equals to minus 1 by 4 is known as the 0 of the polynomial. P of x is equals to 4x plus 1. So again, let me repeat, let us go by the definition, that it is that value, or it is the value of the variable x. It is the value of the variable x at which the value of the polynomial becomes 0. So it is the value minus 1 by 4, and the value of the polynomial p of x became 0 at x equals to minus 1 by 4. Right? So this is how we can find out the values of the given polynomial, and we can also find out the 0 of the polynomial. It is clear, friends? So how we can get the zeros of the polynomial? Everyone, it is clear, friends? It might be very easier for you to identify that whether they are zeros or not, because in this chapter about the zeros of the polynomial, we are simply asked to find out whether the given value, a value will be given to you with a polynomial, whether that given value is the 0 of the given polynomial or not. And if it is asked to find out the zeros of the polynomial, then I'll teach you how to find out the zeros of a polynomial. But rather than, you must know how to factorize a polynomial. It is clear how to factorize a quadratic polynomial, to be specific. A quadratic polynomial is factorized, or it can be factorized into two different factors, and you must know that how it can be factorized, because there is no such time here that I can explain you whole the factorization process, but I will explain you how it can be done. Okay, friends? Now I am having some questions that find out the values, find out the values of the polynomials, find out the values of the following polynomials at the given indicated, or at the given values of variables. I'm having the first one here. Find the value of p of x is equals to 5x cube minus 2x square plus 3x plus 2 at x is equals to 4. I need to find out the value of this given polynomial at x equals to 4, right? So how to find out the values, as we discussed in the previous topic here, that we put x equals to minus 4 in this and let us verify that are we getting 0 or not. But here in this question we are not asked to find out the zeros, friends. See, we are not asked to find out the zeros. Whatever the value we get here, that is to be found out and written. So given p of x is equals to 5x cube minus 2x square plus 3x plus 2, right? And we need to find out at x is equals to 4. That means each and every x in this polynomial, in the given polynomial, will be replaced by 4. Whatever the x or how much quantity of x you see here will all be replaced by 4. But note that we are not going to replace the coefficients and the powers. We are going to keep that as it is. So p of x, that means p of 4 now, because x has been replaced by 4, that is 5 into 4 cube minus 2 into 4 square plus 3 into 4 plus 2, right? P of 4, p of x, as we discussed, simply means polynomial in variable x, and p of 4 here that I have written, it simply means that the value of the given polynomial at x equals to 4. P of x was a variable, or it was a polynomial, and p of 4 that we will get here will be a constant value, that will be a numeric value. Is it clear, friends? So let us simplify this. That is 4 cube, that is 64, and 5 into 64 minus 2 into 16 plus 4 into 3, 12 plus 2. So 64 into 5, that is 320, minus 16 into 2, 32, plus 12 plus 2. Is it clear, friends? So 320 minus this, let us simplify this, that will be minus 20 and minus 18. So that is, I think, 302. Yes or no? Yes, it will be 302, and that is p of 4. So the value of the given polynomial at x equals to 4 is 302. That is p of 4. Okay, so the value of this given polynomial at x equals to 4 is 302. Let me solve one or two of the same kind, and then I shall give you one or two in the self-study. The second one, p of x is equals to 5x cube plus 2x square plus 3x minus 8 at x equals to 0. It is quite an easier one. You can solve this orally, because we need to find out the value of this polynomial at x equals to 0. That means whatever the variables that you see here in the question will all be 0, or will all be replaced by 0. Therefore p of 0 is 5 into 0 cube plus 2 into 0 square plus 3 into 0 minus 8, right? 0 cube, that is 0, because 0 into 0 into 0, that becomes 0, and 0 cube into 5 is again 0, so that is 0 plus 0 plus 0 minus 8, which is equals to minus 8. Hence p of 0 is equals to minus 8. Okay, friends, so that is how you can find out the value of the given polynomial at x equals to 0. Let me solve one more. the third one, that is g of y is equals to 3y cube minus 4y plus root 11 at x equals to 2. Right? We are having this question, g of y equals to 3y cube minus 4y plus root 11 at x equals to 2. So let us find out the value of this. Therefore, g of 2 is equals to 3 into 2 cube minus 4 into 2 plus root 11. Right? Now what is 2 cube? That is, I think, 8. Right? So that is 3 into 8 minus 4 into 2, 8 plus root 11. 8 into 3, 24, minus 8, that is 16. Hence, that is 16 plus root 11, and that is the value of g of x at x equals to 2. Right? Note that, friends, this root 11 here is an irrational number. Right? It is not a real number, whereas, it is not a natural number or a whole number, whereas 16 is a natural or whole number. Right? So you cannot simply add this root 11 to 16, because both the numbers are of different categories. The first one is a natural number or whole number, if you say, and the second one is an irrational number. You cannot simply add them, because as we seen in chapter number 1, the operations on real numbers, that you cannot simply directly add an irrational number with a natural number. Is it clear, friends? So that is 16 plus root 11. Fourth one, it is given like p of t is equals to 4t raised to 4 plus 5t cube minus t square plus 6 at t is equals to a. See, friends, here in this question it is asked to find out the value of this polynomial at t equals to a. That means you are going to simply replace all the t's given in the question by a. That means that p of a is equals to 4 into a raised to 4 plus 5 into a cube minus a square plus 6. As we know that the value of a is not given, right? Simply it means that a will be kept as it is, and hence that is equals to 4 a raised to 4 plus 5 a cube minus a square plus 6, and hence that is the answer of the given polynomial. That means the value of the given polynomial at x equals to, at t equals to a is the same as that of the question, but all the t's are now being replaced by a. Okay. So that's about finding out the values of the polynomials. I'm having some more questions here with me. Let us solve it here itself. See, friends, you can also do this by writing down the questions and without looking at the solutions here, and then you just verify your answers with the given solution, so that it will be easier for you to practice. Right? So that was the fourth one. I think we solved it recently. Now the fifth one. See, it can be asked like this also, that find the values of, or find p of 0, p of minus 1 and p of 2 for p of x is equals to 5x minus 4x square plus 3. Right? We need to find out these three, p of 0, p of minus 1 and p of 2. Now what does this mean, friends? If I say to find out this p of 0, p of minus 1 and p of 2, it simply means that we need to find out the values of the given variable p of x at x equals to 0, x equals to minus 1 and x equals to 2. So first of all, finding out p of 0. So given p of x is equals to 5x minus 4x square plus 3, and hence therefore P of 0 is equals to 5 into 0 minus 4 into 0 square plus 3, that is 5 into 0 0 minus 4 into 0 is again 0 plus 3, which is equals to, let me write down here, 0 minus 0 plus 3, and hence P of 0 is equals to 3. Okay, P of 0 is equals to 3. So that is the value of P of 0. Similarly, we can also find out P of minus 1, that is 5 into minus 1 minus 4 into minus 1 square plus 3. 5 into minus 1 is minus 5 minus 4 into minus 1 square is 1 plus 3, that is minus 5 minus 4 plus 3 minus 9 plus 3, and hence P of minus 1 is equals to minus 6. Clear with this, friends? Right? And the last one, that is P of 2. Therefore P of 2 is equals to 5 into 2 minus 4 into 2 square plus 3. So that is 5 into 2, 10 minus 4 into 4 plus 3. So that is 10 plus 3, 13 minus 16, and hence P of 2 is equals to minus 3. So we got the values of all the three terms or all the three questions asked in the given question. Okay, so that is how we can find out P of 0, P of minus 1 and P of 2. Is it clear, friends? Right? Okay. Let me write down one of the question here. The sixth one. Find P of 0, P of 1 and P of 2 for the first one. Given P of x is equals to x minus 1 into x plus 1, and the second one P of t is equals to 2 plus t plus 2t square minus t cube. You will try to do, or you will try to solve this sums here written. The sixth one, that is find out P of 0, P of 1 and P of 2 for given P of x is equals to x minus 1 into x plus 1, and given P of t is equals to 2 plus t plus 2t square minus t cube. You will try to do this in homework, or you will try to solve this by self study, right? So that you can come to know how to find out the values of the polynomials. Is it clear, friends? So that's it about finding out the values of the polynomials at the given values of the variables. Now we were talking about the zeros of the polynomials. So let us try to find out how it works and what the zeros of any polynomial will be, how it can be found out for a quadratic polynomial and for a cubic polynomial. So the very first question right now here with me is, check whether 2 and minus 2 are the zeros of the polynomial P of x is equals to x plus 2. Quite the easiest one given in the book here. We need to check whether this 2 and minus 2 are the zeros of the polynomial P of x is equals to x plus 2 or not. Now, how to check for the zeros with the given values? We shall simply put down this 2 and minus 2 in the given polynomial P of x is equals to x plus 2 and look for the values that are we getting 0 in any case or not. So first of all, what we are going to do? We are going to find out given P of x is equals to x plus 2. Now finding out P of 2 and P of minus 2. Right. So friends, see, the first topic, that means the previous topic, finding out the values of the given variables, given polynomial at the given values of the variables, that was not in vain, because that is helpful in finding out or in checking whether the given values of the variables, or the given values of the the given values are the zeros of the given polynomial or not. So finding out P of 2 and P of minus 2. So first of all 2, that is 2 plus 2, which is equals to 4, and that will be minus 2 plus 2, that is 0. So we shall look now for those values of the variables at which we get the value of P of x equals to 0. That means if we get P of 2 equals to 0 and P of minus 2 is equals to 0, then both the values are the zeros. But here we got P of 2 is equals to 4 and P of minus 2 is equals to 0. So coming to the conclusion, so 2 is not a 0 of P of x, but minus 2 is a 0 of the polynomial P of x. Right? 2 is not the 0 because at 2, or the value of the polynomial P of x as at 2 is not a 0. In fact, it is 4. So that is not the 0 of the given polynomial, but minus 2 leads us to P of x or P of minus 2 equals to 0, and hence that is the 0 of the given polynomial. Is it clear, friends? Similarly, we can also verify some more of the questions. Now let us quickly see how to find out the zeros. In the next question we are going to see how to find out the zeros, and then we shall practice for some of the questions. So second one, find the zeros of each of the given polynomials. We need to find out in each of the following cases. Under that, the first one is P of x is equals to 2x plus 1. So in these cases, how to find out the zeros of the polynomials, that is the value of the variable x we need to find out. We are looking for that, right? But in the question that we have started with, there we have randomly taken the value of x, but now here let us find it out by the proper method. So to find out the zeros, let here given P of x is equals to 2x plus 1, let P of x is equals to 0. Therefore 2x plus 1 is equals to 0. Therefore 2x is equals to minus 1, and hence x is equals to minus 1 by 2. See friends, we got the value of the variable x. We needed to find out the value of that variable x. We got 1. Now let us check that is it the value or is it the 0 of the polynomial or not. Therefore verifying or verification, given P of x is equals to 2x plus 1, therefore P of minus 1 by 2 is equals to 2 into minus 1 by 2 plus 1. This 2 and 2 can be cancelled, that is minus 1 plus 1, and hence which is 0. So we got P of minus 1 by 2 as 0. That means the value of the variable x that we got here is actually the 0 of the polynomial, and which means that to find out the zeros of a polynomial, we simply need to know, or we simply need to assume that let p of x is equals to 0. Assuming the very first condition that we are going to have it is assuming that p of x is equals to 0. It must be 0 because we need to find out the zeros. That means we are looking for those values of the variable x for which the polynomial is 0. In that case, friends, first of all, let us assume that it is already 0. If we assume that it is 0, then we are going to get some values of x such that it will be the 0 of the given polynomial. Okay, so that is about the first one. Let me write down another one here. That is the second question. Given polynomial p of x is equals to 3x minus 2, right? I'm writing down another question here also, that is 3x minus 2. So what is given here? Here given p of x is equals to 3x minus 2. So let p of x is equal to 0. Therefore 3x minus 2 is equals to 0. Therefore 3x is equals to 2, and hence x is equals to 2 by 3, right? So we got the value of the variable here, x is equals to 2 by 3, and in fact I think that must be the valid because we have started with the assumption that let p of x be equals to 0. Therefore let us verify the verification. Given p of x is equals to 3x minus 2, so we shall find out 2 by 3, that is 3 into 2 by 3 minus 2, 3 and 3 can be cancelled, that is 2 minus 2, 0. So p of 2 by 3 is equals to 0, and hence the value that we got here for x, that is 2 by 3, is a valid one. Hence the 0 of the given polynomial is x equals to 2 by 3, and same as that we got for the first one, that is x equals to minus 1 by 2. Is it clear, friends? Okay. Now, how we got the zeros of a polynomial, right? That was the easy task for us to do here. Now let us again come back to finding out or verifying whether the following given values are the zeros of the given polynomial or not, right? So again, writing down the question here, check whether the values of variables given are the zeros of the polynomial or not. The first one under that, p of x is equals to 3x plus 1, 4x is equals to minus 1 by 3, right? So we are having this polynomial here, p of x is equals to 3x plus 1, 4x is equals to minus 1 by 3. Note that here we need to check whether this is the value of the given polynomial or not. So for that we are going to do here, given p of x is equals to 3x plus 1, and therefore p of minus 1 by 3, that is 3 into minus 1 by 3 plus 1. So we can cancel out this 3 and 3, which leads us to minus 1 plus 1, which is 0. Hence, or therefore, we can say that P of minus 1 by 3 is equals to 0. If P of minus 1 by 3 equals to 0, the conclusion, yes, given x equals to minus 1 by 3 is a 0 of P of x, right? Given x equals to minus 1 by 3 is a 0 of the given polynomial P of x. Then the second question, given P of x is equals to 5x minus pi at x is equals to 4 upon 5, right? It is 5x minus pi, friends, pi. So again, let us start with the same process that we are going to do here, that given P of x is equals to 5x minus pi, therefore P of 4 upon 5, that is 5 into 4 upon 5 minus pi. Thus 5 and 5 can be cancelled, which is 4 minus pi, right? This is 4 minus pi, which is not equals to 0. Therefore P of, sorry, my mistake, not minus, P of 4 upon 5 is not equals to 0. Conclusion, no, x equals to 4 upon 5 is not a 0 of P of x, right? So this is how you can write down the conclusion, that whether it is a 0 or a not a 0. Again, let me write down one more question here, that P of x is equals to x square minus 1 for x equals to minus 1 and 1. We need to check whether both of this, minus 1 and plus 1, both of this are the values of the given polynomial or not. Okay, let us see this here, or given P of x is equals to x square minus 1, therefore P of minus 1, that is minus 1 square minus 1. What is minus 1 square? 1 minus 1, which is equals to 0, and therefore P of 1, that is 1 square minus 1, that is 1 minus 1, which is again 0. So in both the cases we got the value 0. Therefore, yes, minus 1 and 1 are the zeros of the polynomial P of x, right? Minus 1 and 1 are the zeros of the given polynomial P of x. The fourth one, let me see here, that is P of x is equals to x plus 1 into x minus 2 for x is equals to minus 1 comma 2. We need to check whether minus 1 comma 2 are the zeros of the given polynomial or not, right? Let us check it. First of all, what is given here? Given P of x is equals to x plus 1 into x minus 2. Therefore, first of all, we shall find out P of minus 1, that is minus 1 plus 1 into minus 1 minus 2. What is minus 1 plus 1? 0 into minus 3. What is this equal to? 0. So we got P of minus 1 as 0 here, right? Here also we got 0 in both the cases. And P of 2, that is, let us put it here, 2 plus 1 into 2 minus 2. What is 2 plus 1? 3 into 2 minus 2 is 0, and hence that leads us to 0, because 3 into 0 is 0, right? 3 into 0 is 0. So we got P of 2 as 0 here. Therefore, yes, minus 1 and 2 are the zeros of the polynomial P of x. Is it clear, friends? So that is how you can find out check whether the given the given values of the variables mentioned are the zeros of the given polynomial or not.